Manufacturing Matters is an MFG Radio Network production brought to you by GIE Media's Manufacturing Group as industry experts take deep dives into the latest manufacturing matters, whether it's new innovations, products, technologies, and emerging markets that help you understand better why manufacturing matters to you and also to the top companies in the medical, aerospace, defense, and electric vehicle manufacturing industries. Hello and welcome to the latest roundtable discussion from GIE Media's Manufacturing Group as we discuss designing and manufacturing for electric vehicles. I'm Jake Kaufman, a managing editor here at GIE, and the panelists are standing by waiting to answer questions about how to adjust and pivot when the industry is moving from internal combustion engines to EVs. First, however, we would like to thank today's sponsors, Festo, Iscar, and Sandvik Coromant. Festo has set standards in industrial automation technology and technical education ever since its establishment, thereby contributing to sustainable development of the environment, the economy, and society. The company supplies pneumatic and electrical automation technology to 300,000 customers of factory and process automation in over 35 industries. Iscar is a full solution provider of metal cutting tool products and accessories for CNC machining, launching hundreds of new products for machining each year. Iscar is where innovation never stops. And Sandvik Coromant is at the forefront of manufacturing tools, machining solutions, and knowledge that drive industry standards and innovations demanded by the metalworking industry now and into the next industrial era. Educational support, extensive R&D investment, and strong customer partnerships ensure the development of machining technologies that change, lead, and drive the future of manufacturing. Now, before we get to today's discussion, we would like you to know just a little bit about our panelists, as we are joined by Jared Garby. He is an industry segment manager at the Automotive Group with Festo North America. His expertise includes solutions that support the electrification of the powertrain. This includes cell handling, modular and pack assembly, and electric motor production solutions. Jared has held various roles at Festo over the past 10 years. He holds a mechanical engineering degree from the University of Illinois, Urbana-Champaign, and an MBA from DePaul University. Also, Andrew Benson is the president and chief marketing officer at Iscar USA. Benson started with Iscar in 1984 as a cutting tool design engineer and has held several positions before currently serving his position as the president CMO for Iscar USA. He is a graduate of Penn State, receiving an MBA along with degrees in accounting and mechanical engineering. Andrew has more than 35 years in the metal cutting field. And finally, we also at Sandvik Coromant are joined by Rick Crabtree. He is the product solution manager, bringing more than 38 years of manufacturing, engineering, and application support experience to his role as a production specialist in automotive aluminum. In his 24 years at Sandvik Coromant, he has led global teams responsible for productivity improvements and helped customers achieve millions of dollars in cost savings. Rick understands the challenges and the needs of machine shop floor and equipment customers with application knowledge and techniques to optimize operations. Rick leverages his mechanical engineering and industrial management education from Central Ohio Technical College and The Ohio State University, respectively, and is committed to advancing automotive aluminum machining. So without further ado, let's begin. So we begin with Andrew over at Iscar. Now, Mr. Benson, how much of your company's focus is on electric vehicles compared to internal combustion engines, and how has that changed in recent years?
So, we have put a focus on EVs really from the standpoint to understand the change in the market. The automotive market is one of the biggest consumers of cutting tools, as Rick will probably also agree with. And, so this is a fundamental change for our companies. And, so what we've done is basically we took a segment of our engineering department in Israel, and we basically tasked them to go out and review these different components, work with the machine tool builders, and also with the companies themselves like a Volkswagen, BMW, Tesla, and determine what the machining characteristics were of each one of the parts, and then begin to form a machining strategy for those. But the end of the result is it's really, there are some similarities and there's a lot of differences. The similarities, remain in maybe braking, steering, suspension, those things. But there's obviously the way it's powered. It's an EV. It's completely different, and it's going to change significantly our approach, and it will impact certainly the way you know uh, the way we offer solutions to these particular companies over the ICEs.
Awesome. Thank you, Andrew. So, Rick, over at Sandvik Cormont, we will ask you the same question. Just how much of your company's focus right now is on electric vehicles compared to the internal combustion engine, and how has that kind of changed in recent years?
Yeah, so if we would, go back 8 years, it was probably 95%, ICE, right? And 5%, some alternative way that we're going to, power these vehicles, and to the forefront now is the EV, right? So probably if we would fast forward to now, it's probably 60-40. We're spending 40% of our time on developing new cutting tools for the EV market. And like Andrew said, there's a knowledge that you have to gain, understanding what the customer needs are. And so like their group, we developed, global task teams to first get that knowledge. And now, in the last 3 to 4 years, we are looking for the development in those type of arenas.
Awesome. Thank you, Rick. So now we'll bring Jared into the conversation. As at Festo, are there parts of your product line that you've been able to expand in part due to the demands of EVs, or is it something that you guys have already had?
Yeah, so it's certainly absolutely. I mean, we've absolutely invested significantly in products. We approach this. We have the electric vehicle side, but then we have this. We call it the battery ecosystem, right? Where we've considering everything from the mining of the raw materials all the way through the implementation of cells into the pack that goes into the vehicle, back into maybe the recycling or the reuse side, and then putting maybe the recycled components back into the system. We have from process valve assemblies to help on the mining side to control the different media that's required. There's a lot of different types of aspects of that, whether it's corrosive media, you have to have the right metals, the right coatings. So we do a lot of that. You see that also inside these gigafactories where they're making the cells when you're bringing in the batch media process. Additionally, when you start making the cells, the electro process has a lot of unique requirements that we've had to adapt the product line to, right? So you have products that we require copper, zinc free variations of, where if you can't, because you cannot have any particulates enter into that process because it can degrade the quality of the cell in the long term. And then I'd say the biggest aspect that we see right now, or the biggest opportunity in North America, is on how you handle these cells. When the cells are being produced, you're putting these cells into the pack, into the module. We spend a lot of time developing different types of solutions around gripping, maybe vacuum picking, magnetic gripping, all ways to pick up cells, and then putting those into the cells through like our Cartesian handling system. So this is like pick and place systems. We do a ton of that, and it's been a nice opportunity for us going forward. So it's been a mix of, we had the existing product line, but then we've absolutely had to adapt for the unique requirements that are presented in the industry.
Awesome. Thank you, Jared. So, Rick, we'll go back to you with the same question. Are there parts of your product line that you expanded to work with EVs, or is it mostly things that you guys had already had on hand?
I wish I could say we had it all on hand, but we did not. We had some e-motor technology and some ideas, and we went out and had to understand, battery trays and can we get contaminants like Jared said into the battery tray, so they got to be sealed. So we developed some things to make gasket surfaces, and for the e-motors, all the big stator bore housing tools and things like that, you know, they're huge. And as we look at machine manufacturers, they are shrinking the envelope of what they want to uh, the machine size. So, you know, if they were 800 millimeter pallets, now they're typically 600 millimeter pallets. And their reasoning is they want to go faster from point to point.
Mhm.
And when they go faster point to point, they can lower the cycle time, which in the cycle time arena, the cutting tools are not the longest. It's the tool change and in the point to point is takes up all your cycle time. So that's where they're shrinking those. They're also shrinking the size of the spindles. There's no more, there is, but there's less and less like HSK 125s, and now they're trying to do them with HSK 63s or HSK 100s. You know, a lot smaller envelope, but they can run these things faster. You know, 20,000 RPMs and things like that. So yes, we've developed a few tools for this.
Awesome. Thank you, Rick. So, Andrew, if you want to wrap up this round of questions for us, over at ISCAR, are there parts of your product line that you were able to expand to work exclusively for EVs?
Yep. So the EV, you know, the big change is it's a lot of finishing work, you know, because the parts are near net. And, you know, if you look at the material mix, it's aluminums, it's electric iron, you know, high silicon iron, also steels, you know, and in some cases hardened steel. So the inserts themselves, the cutting tools, you know, with it's a cemented carbide or it's PCD, polycrystalline, or CBN, you know, we'll still have those basic tool materials in play, but, you know, it's the approach that's different. And so where we're working with in terms of developing new types of approaches is, you know, we'll have combination tools. There's quite a bit of that with, you know, EV production to be able to, you know, finish different surfaces all in one motion with a tool. And then that leads to, you know, what are the requirements to be able to use that, you know, like Rick was saying, when you have something in production, you want to have an ease of use that goes with it. So, you know, we've really focused on, you know, quick change, indexability of the tooling, of the inserts. So it's highly repeatable. And in different, and also to build in adjustability, you know, for these, you know, multi cutting edge tools, you know, these combination tools to be able to adjust if needed, the cutting edges in relation to each other to machine it. But, you know, like I said, it is a lot of finished machining, and the actual cycle times of when, you know, being in cut relative to an internal combustion engine are much lower. So you start looking at other aspects of the tooling like quick change, repeatability, things like that.
Thank you, Andrew. So for the next round, we'll stick with you for this one. Now, you know, it's not usually an overnight thing to get these kind of manufacturing, this kind of manufacturing up and running. So when did you kind of start talking to the OEMs, the suppliers, to kind of make this transition from ICE to electric vehicles?
You know, it's I can't really give you a date as to when we started, but, you know, as we started to see the parts come through the builders, because that's typically where the projects begin. And then we, you know, obviously this is new, we begin looking at it. And even at that point, the EV manufacturers themselves, you know, these are the components that they need, but they're really relying, you know, on the community, on the builders, et cetera, to take it up as a project and then, you know, to be able to machine the part. On the converse of that is the actual suppliers that are the small shops that are getting these components to make for the EV manufacturers that have to use the same capital equipment that they have in place. And so we do work with them as well, you know, to try to make a fit between what they have and what they need to produce, you know, considering the differences in, you know, what they were producing in the past in terms of automotive parts. But, you know, I would say we probably started the journey, you know, right around probably 5 or 6 years ago, you know, more intensely, you know, looking at all the different components, mapping out what's the change from the internal combustion engine, where do we need to focus? And, you know, the end result is it's just simply, it's a lot less metal removal. Parts are basically more near net, and but there's certainly a lot of high precision to it, and in many cases the tooling is more complex because it's combination tools with adjustability.
Awesome. Thank you, Andrew. So Rick, we'll go back to you over at Sandvik Coromant. So when did you guys kind of start having the conversations with the OEMs and the suppliers about making the switch from ICE to EV, and kind of how has that process gone about?
Yeah, so it's definitely driven by machine tool builders, and it's because of their customer needs, correct? If a OEM of automotive manufacturer needs to make something, they go to the machine tool builders first to get the machinery and the envelope size. For us, it's kind of been a journey that started with diecast, the aluminum manufacturers. So that's where we got our feet wet into this, and that's been 8 to 10 years. And now, if you look at where we started 8 to 10 years ago to now, there's still so many different avenues that they could go. Some people are putting transmissions on the EV engine, some of them are EV alone, and so it's not like an ICE vehicle that it's either it's a 3-cylinder, a 4-cylinder, a 6-cylinder, an 8-cylinder. They may be a V or a flat-headed engine block. There's everybody's idea is custom when it comes to EVs right now. It's not quite the wild west, but it's similar to, well, this is how I think it ought to go, and that manufacturer goes that way. So we're looking at, we have to be prepared, to meet the customer needs, whether it's the machine tool builder or the end OEM guy. But like Andrew said, the small tier plant that's making maybe something else, that they may bid on an EV project to start out just to make the first 200 engines for R&D. And they're taking their equipment and they're just, they got to figure out how to make it. So they want more standardized tools where we can make custom tools to the larger OEM guys, where we can combination and quick change and do a lot more out of operations to a cutting tool.
Awesome. Thank you, Rick. So Jared, we'll go back to you. Now, I know when we were talking about the expanding of your product lines, you mentioned the Cartesian system when it comes to producing the EV cells. So why is the Cartesian system well suited for electric vehicles? And were there other, options that you had used and really settled on the Cartesian system?
Yeah, I mean, from our perspective, obviously when you're moving, anything around, there's lots of ways to accomplish this, right? But a Cartesian system really has from like 4 major advantages from my side. Because your workpiece is typically very close to the carriage and how you're moving, you're operating directly over your component. Your center of mass is reduced. So this allows you to achieve higher speeds because you have less moment, less inertia in the system. Additionally, like a Cartesian system, if you want to think about it, like as a 3-dimensional XYZ, you're really utilizing that entire footprint. And so there's a lot of value in that, particularly as guys are retrofitting their facilities. It also makes it really well suited for like maybe the station to station type design that you might see in the manufacturing process. Another advantage is they're very accurate. They maintain their accuracy throughout the whole scope of the system. So if you want to, whether you travel to the far end of the x-axis or the far end of the y-axis, you maintain that very high accuracy that you would expect from, like in this case, like a belt-driven or a ball screw-driven system. And then finally, they're cost-effective, right? They're a great solution. We found that a lot of the line builders, a lot of the OEMs, they're all everybody is trying to understand what the best way to accomplish the different steps within the process of either, in this case, module and pack loading or electric motor and stator assembly. This is all, and I think what we've seen is the Cartesian system does provide some unique benefits over other solutions in the market. And so that's been really exciting for us.
Awesome. Thank you, Jared. So, Rick, we'll go back to you at Sandvik Coromant with our next round of questions. Now, obviously, EVs have less parts that need to be machined compared to an internal combustion engine. So, there are still things, though, that do need to be machined, whether it's aluminum housings, battery housings, structural components, some of the gears. So, how do you kind of help your OEMs and the suppliers make the transition with having less parts to machine?
So we have a group that directly calls right on the machine tool builders, and their motto is right from the start. They want to make it perfect right from the start. So they have direct access to R&D. They have, auto design teams and things like that. So we can do, finite analysis on strength of our cutting tools and make sure that we give our customers the right things, from the start. A lot of this, there is a lot less components, but that doesn't mean that they're not, as accurate as anything, any other component. Like if we look at the EV motor, there may only be plus or minus 30 microns, from bore to bore. So, and they probably want to do it all from one clamping system, so there's not rotation of the tools, so they're all in line. So there's a lot of engineering that's going involved with making sure that we do, less. There is less opportunities or less components, but they have to be perfect when you go through them.
Awesome. Thank you, Rick. So, Andrew, we'll go back to you with the same question. Obviously, with less parts to be machined, how are you kind of helping your OEMs and your suppliers make that transition?
Yeah, so I think Rick made some great points there, and the precision is very important in these parts, because you take a conventional ICE and you're turning max maybe 6,000 RPM. With an electric motor, you're 20,000 RPM, and so there needs to be more precision in some areas versus the ICE. But I think where we're focusing is the actual change itself to this type of vehicle. It's more near net shape machining, so the cutting tools actually can be downsized. You don't need the conventional depths of cut of 1/4 inch or 300 thousandths of an inch. Now you're doing more finishing machining, maybe it's 50 thousandths of an inch, and so the cutting tool can be right sized for that application. And the whole thing with the EV movement is sustainability, right? And so from a carbide supplier standpoint, we can actually provide tools where there's actually less consumable in the process to manufacture. So we're kind of focused on these areas to right size and approach the parts in the right way. But it is a lot of adjustability, as mentioned before, combination tools. And we've been taking it really as a project. So when we work with, say, a Volkswagen, and we look at the motors that they're going to be producing, we look at the casings, we look at the rotor shafts, and we basically optimize on a project basis, basically providing a full solution set to make the part. And as we go, we learn, and then we see the next manufacturer, and they're doing maybe something a little bit differently, and slowly we're building our knowledge. So that's more or less how we're approaching it.
Awesome. Thank you, Andrew. So, Jared, we'll go back to you at Festo. How do pneumatic and electric actuators help in the production of EV batteries?
So it's really our ability to, obviously we can offer both solutions, right? So from a pneumatic side, pneumatics remains a very cost-effective way to do a lot of different functionality, a lot of different mechanics. You get high force, you get a lot of speed. It's very highly repeatable. And then you can also utilize pneumatics to do gripping, vacuum, anything, all these typical, as anybody that's used pneumatics over the years is pretty familiar with how it plays out. Simple movements, pneumatics is very attractive. Where electric automation, what it brings to the table is a little bit like flexibility, right? You get a higher level of control, you get multiple positioning, you get more feedback on your process. The more complex motions, like think of, from our perspective, like dispensing an adhesive or paste, or just the picking and placing of cells at a very high speed, where you're moving, you're placing 1,000 cells in the pack, or, or a module per se. This is where electric automation really has a unique advantage and pneumatics just simply doesn't play in that. In truth, though, most of our customers are using a combination, right? They're using maybe pneumatics on the end of arm tooling, and then you're doing the electric automation on the larger mechanical movements to allow you the flexibility you need. So I always, Festo, our unique value in my opinion is our ability to offer both. But we do, we're going to find the best solution for the customer and for the application, since we're really able to offer both solutions to our customers.
Awesome. Thank you, Jared. So, Andrew, we'll go back to you at ISCAR. As we've talked about the different OEMs and the suppliers that you guys do have, when we talk specifically about the smaller OEMs and the suppliers that you work with, what is it like for them going from an ICE, manufacturing process to an EV? What kind of are the things that you tell just the smaller suppliers, the ones that, don't have these massive factories making all the different parts?
Yeah. So, our advice to the smaller suppliers, I think the conventional machining approaches work to, some degree, that they can use the equipment that they have in place to be able to do it in a lot of cases. The thing that we can bring to them is, we have knowledge because we're working with the builders that are working directly, with the large automotive companies that are making these, to kind of understand what those parts look like and how we're approaching them, and to see how can we use what they have in their shop to be able to approach it the same way. It's really more about sharing our experience and knowledge with them, because obviously they're a local entity. They have very limited resources and maybe scope on and experience, and we're a global company and we're involved with many different companies. And so really it's like, I think it comes down to knowledge as we gain it, and we see opportunities and basically to help our customers in that regard.
Awesome. Well, Andrew, that actually kind of goes into the next question. So we'll hit Rick up with this one, and then we'll come back to you. But Rick, over at Sandvik Coromant, how do you guys kind of work with the smaller OEMs and the suppliers who are making that transition from ICE to EVs?
Yeah. So a lot of times their overhead's a lot less. So they don't mind, maybe making a production part that takes a little longer. So if they can use a D-Vibe tool, a D-Vibe bar, anti-vibration bar with a boring unit on the end of it, they don't need that combination tool. So they don't need to spend that money on, that. And they'll do more like modular type tooling and stuff that they can quick change around so they can be competitive. A lot of times, like I stated before, they may only make 200 of these electric engines, or they may only, do 50 battery trays to go be tested at, the OEM. And while they're doing that, the OEM guy is making the big production run, or, equipment and line change and things like that. The one thing we haven't said a lot about yet is the interim. What's going to happen? The interim is more the hybrid vehicle, where it'll have both units together in the automotive industry.
Awesome. Thank you, Rick. So I know this is something that Andrew had mentioned, so we'll go back to you with this. So the knowledge that you guys have of working with electric vehicle parts and in the production, how do you kind of educate and train your customers and even your own employees when it does come time to, work with or use these EV parts?
Yeah, so I'd like to just make a shout out to my friend Yair Select in Israel. He was actually the one that led this project. He's our automotive guy over there, and very sharp man. But what they did is basically working with all these different builders and then working with the OEMs themselves. They basically took the parts, the finished units digitally, and exploded everything out, and then part by part put together a working presentation for the entire company globally, which they then gave. That's how I learned about EV machining from him. And, we just basically took it part by part. And then obviously we're matching up what our current cutting tool portfolio is to those given parts, and then looking at, what are the specific needs for these parts to be able to machine them in the quickest possible and most efficient way. So really, that's how the training began. And then once it went to our sales team, then our sales team would approach anybody that's making an EV part, looking at it now from a component standpoint and an application standpoint, because you're not typically seeing one supplier making an entire motor. They're making maybe the rotor shaft or something else. And so we're able to select that specific part and then look back through our materials to say, this was the best practice for making that part. So that's how we did it.
Awesome. Thank you, Andrew. So yeah, Rick, we'll go back to you with that same question too. As far as the education, the guidance, how have you kind of worked with your customers and even your own employees when it does come time to make the switch from an EV part manufacturing from ICE part manufacturing to EV part manufacturing?
Yeah, very similar. We develop, we have a training, I guess, group that we call the Sales Academy. And in the Sales Academy, they develop how to and best practices globally of what knowledge we've found, throughout the world, that, if it's a hollow shaft, or if it's a stator housing or a battery tray, what's the best solutions? And just like Andrew said, we've broke those down to all the areas, and that's how we attack that. And then with that, we train our sales group, and our sales group then has the knowledge to go to all their customers and give them, guidance on how to manufacture these parts.
Awesome. Thank you, Rick. So Jared over at Festo, we'll go back to you for the next round of questions. So speaking of customers, if there is a potential customer who wants to get a Festo system for EV production, what kind of is the installation process like? How long before it would be up and running in their factory?
Okay. Yeah. So, I mean, as we go back to some of what we talked about earlier, it's, we've spent a lot of time developing the solutions, but we also spent a lot of time developing the software and the tools to help with these systems. So I always want to mention the design side of these systems can all be done online through us. You can go online, you can configure the parameters that you need for your system in, a few minutes. And within 5-10 minutes, you're going to get a full CAD file that you can implement into your system with cable bearers, motors, if you can picture one of these systems. It's a really fully configured solution. So, additionally, when we talk about the installation, when you try to simplify this commissioning for our customers, right? So we've developed something we call our motion control platform. It's a plug and play approach. It's a panel that has all the drives, all the controllers, all your I/O contained within it. You plug it in, you connect it to your PLC, whatever your protocol is, and it's going to have your preloaded motion profiles. It's going to have your settings, and you're going to be able to get this system online very quickly. And we test the mechanics of these systems at our factories, our facilities here in North America. And when we test them, then we break them down. And typically you're going to receive your system fully assembled. Maybe it's broken down into 2 parts so it can fit inside of, if it's a larger system. But you can I've seen customers get these systems commissioned and online in an afternoon. Absolutely. So it's we've really tried to streamline this process. Time is money for all of our customers, and we understand the value that the right engineering tools and the right products and how they're delivered to you brings to our customers.
Awesome. Thank you, Jared. So Rick, we'll go back to you at Sandvik Coromant. So when it comes to the materials that are being machined, being cut to make EV parts, how are they kind of different than those used in ICE cars?
They're new, and they're hard to fixture. So, and if we look at them, 10 years ago, we didn't have 80% aluminum in a vehicle, and now it's getting to that range. And there's bimetal stuff, and there's 3D printed stuff, and there's carbon fiber stuff, but a lot of it's getting ready to be fixtured, and fixturing is going to be some of the challenges right now for us. But we're quickly really overcoming those with unique designs, and that comes from our automotive project offices. We have R&D or for our customers to use those R&D places to machine their parts, and we can bring their fixturing or design something ourselves to do those to help you know beat that burden.
Awesome. Thank you, Rick. So Andrew over at ISCAR, we will ask the same question. How are the materials changing between ICE and EVs, and kind of, what are you seeing on the front as far as materials being used?
Yeah. So I agree with Rick, and it's more or less the same explanation. But with you think about EVs, one of the challenges is they have to reduce the weight of the vehicle, right? Because when you put a battery in there, the battery is so heavy, any incremental changes you can make to lightweighting the structure is going to allow it to be more efficient and safer on the road. So we're definitely seeing a lot more aluminum, and it does bring into question, as Rick mentioned, you have parts like housings and that are thin-walled parts that are being machined. And so there's some care that has to be exercised with that. We're also seeing, just basic steels, high silicon steels, but nothing really exotic or anything like you'd find maybe in the aerospace industry. So I don't think that there's really big challenges to machining the materials. It's more or less just holding the materials and making tooling to do multiple operations at once. We are seeing also some composites and glass fiber reinforced materials, specifically with the battery tray areas and things of that. So so more or less it's I think it's easier to cut in general, but it's what you're cutting that's changing and how to cut it.
Awesome. Thank you, Andrew. So Jared, we'll go back to you at Festo. Now, when it does come time to recycle these batteries and also battery pack disassembly, what can kind of Festo do in that process to what kind of role do they play?
Sure. And, this is where we support a lot of different industries. And I think that's where kind of our expertise can help us. Rick had mentioned the Wild West. I think the recycling industry on the electric vehicle side is absolutely the Wild West from my experience. From a process automation side, ball valves, all these butterfly valves, all these things that can control the chemicals that are often used, like on the hydrometallurgy process, where you're trying to introduce salts, acids to the cells to kind of pull out the right, the valuable metals that exist within them. We've done a lot of that so far. And I think that's something we can, kind of unique. And a lot of times people don't recognize us for being able to do that. Additionally, there's a lot, like these facilities have a lot of still like sorting, conveying. We've done a lot of that in just any other market, interlogistics, food and packaging, whatever you want to think of. So that's been a big portion of it. And then probably the most interesting side is like, all right, so how do you disassemble these modules, right? And so we've been at trade shows, we've been talking to customers. We have some examples on our website of a Cartesian system with a cutting tool, maybe something that can be provided from the other panelists, their companies, something along these lines where we're trying to take the lid off these cells in a controlled manner. There's a lot of safety that has to be understood, but just try to get access to the cells inside the modules. And this is where we have the right mechanical solutions, we have the right products. We continue to work with more and more recyclers, and we always want to work with any other recyclers out there to develop unique solutions. But it's absolutely a big focus for us, and we'll continue to develop solutions to support this market, I think, and especially into 2024.
Awesome. Thank you, Jared. So Andrew over at ISCAR will bring you back in for our next round. So are there more areas of EV part production that you see your company getting involved with coming up here soon in the future?
Yeah, so I think it's just an evolution of the current designs, as we're learning what those unique challenges are. So, as the tools are being used in a production environment, then you'll realize, things can be improved. And I think the areas that we're focusing on is adjustability, especially with the combination tools and the ability to deliver coolant through these tools to the areas that are being cut. Really, that's pretty much it. But again, we're mostly focused on taking each one as a project approach and producing a full solution.
Awesome. Thank you, Andrew. So Rick over at Sandvik Coromant, the same question goes to you. Is there an area of EV part manufacturing that you could see your company getting into in the near future that they're not currently involved in?
We're trying to get into
Mhm.
some of these areas, and some of it is going to be like dry machining. And when you start looking at like battery trays, and if you use coolant for areas like that, it becomes a bathtub, and you can
Mhm.
start the machine very, very quick. So dry machining is a lot of it, and as the silicon content goes down and they make more extruded or welded battery trays, we definitely are really focused on MQL, the mist kind of lubricant. And then we're also thinking that there's going to be some alternative styles of energy, whether it's
Mhm.
going to be hydrogen or ammonia or a different thing to produce the charge to charge the battery that then drives the electric engine. So there's a lot of things happening out there.
Awesome. Thank you, Rick. So most of the time that we have been talking today about electric vehicles, it's been cars that we are talking about, but there are obviously more vehicles out there that are electrified now, whether it be trucks or uncrewed air systems. Boats are now electric. There's RVs and scooters. So, Rick, over at Sandvik Coromant, is there any kind of part production that you guys do for these other EVs, not just cars?
Yeah, there's a boat manufacturer that is putting the electric engine or a electric engine in for a pontoon boat, and they're driving the pontoon boats with electric engines now.
Mhm.
There's the hand tools. You start thinking about all your cordless drills and things like that. It's a whole new different challenge. They're not big manufactured parts, but they're small manufacturers, so they can be somewhat difficult, and they want to do the whole process with one tool if they could, outside, inside, and touch a face or something like that. So there's a lot of development there. Um, there I, I think it's, we're just in 2028. If we come back and look at all this, we're going to be, wow, we've grown so much as a global world, in these arenas.
Awesome. Thank you, Rick. So, Andrew at ISCAR, the same question to you. Beyond automobiles, what other kind of EVs have you guys been able to kind of work in the production of?
Yeah, so bicycles is an interesting one, and it's also that's a high volume market. So we've been producing tooling for the housings and the shafts and that for powering those. And but other than that, I think if we're doing something, it's very early on. So I don't
Okay.
really have too much to comment other than the bicycles.
Okay, gotcha. Well, before we get to our last question today, we do have a few questions right now in the audience. So, Eduardo would like to know, and this can go to any of our panelists, should the relationship between universities be increased to prepare new generations to use techniques, or will the talent be prepared internally by each company?
I can jump in on that one
Okay.
if it's all right. So I think it's a combination. I think the university has to supply the baseline education and introduce the student, to the challenges in the industry. And when it comes to, machining, the technical schools, need to really go over what are the challenges with those specific types of materials and the way you hold them, et cetera, and what to look for. But ultimately, and the best practices I've seen is where the company actually takes their staff and then continually has a continual education where they rotate their people
Mm.
through different positions in the company so they get the big picture view of what's happening, and and they grow with the company. But I think ultimately, the challenges of transitioning to the EV is going to come mostly, from the companies themselves and training their own resources. The other thing I think that we need to look at too, from these large automotive companies, this is newer technology, and specifically when you move in a direction of newer technology, you want to take the least amount of risk, right? And so you'll use other companies to actually make the parts for you, and you'll become an assembly operation until you decide, was it make versus buy? Do we bring it in-house and begin to make it? So I think initially, early on here, we're going to see a lot of that, before it starts to migrate maybe to the bigger automotive companies, the actual production.
Awesome. Well, gentlemen, the last round of questions is on us. So we will go to Jared at Festo. As I ask you, and this is something that Rick almost hinted at, if we have the same conversation in 5 years, where do you see the EV manufacturing market?
Yeah, this is an interesting question because, like, I've thought about this, and I think we're going to continue to see the demand on increased throughput just keep going up, right? And we're going to see that fall to the line builders and all the OEMs, and I think so. There's a mechanical aspect to this, right? So we're going to see designs that allow for this, but from our perspective, what we're seeing more traction with is, like, how do you reduce your downtime? How do you increase your operational efficiency? So I think from Festo's perspective, what we're seeing and what we're going to see more of is companies that are looking to, we would call it like the industry 4.0, capture, really do traceability throughout their whole process, right? If you can capture that this cell is there's an anomaly in this cell early in the process, you save yourself a lot of money, you save yourself a lot of trouble, and you prevent just unnecessary scrap. So, I mean, I think gigafactories themselves I think it's something along the lines, almost 50% of the cells they make do not pass, and they have to go back into the process, right? So you have to think that improving this operational efficiency is going to be a huge thing. So Festo, we have a lot of software and a lot of tools that we've been developing that, oftentimes the sensors and all the different checkpoints in the process are already there, but you have to contextualize them, right? So we put them in a dashboard, put them on the cloud, and give your customers access to it. And that right now, that's still seen as very much a premium type offering, right? A premium feature. I think in 5 years, it's going to be standard across the industry.
Awesome. Thank you, Jared. So Andrew over at ISCAR, we will ask the same question to you. We have this conversation in 5 years. Where do you kind of see EV manufacturing at that point in time?
Yeah, I think Rick already gave us a glimpse there, but I think hydrogen is where a lot of investments being made, to produce clean hydrogen. You can see a couple different automotive manufacturers experimenting both with, fuel cell type technology, which actually, if you have the skateboard platform in place, it's basically a function of what's the power source. So that could actually be hydrogen. Also, we see that there's been some recent developments in nanotechnology for storage of hydrogen, and to do it safe. Instead of doing it at 3,000 psi, now we can do it at maybe 300 psi and store even a larger volume. So, I think hydrogen ultimately is going to be a positive direction, for this industry to power these platforms. But ultimately, it'll still be electric. It's just that where does it get the power from? So
awesome.
That's what I think. Andrew. 5 years, we'll be talking more about hydrogen.
Awesome. Thank you very much. And then we go to Rick at Sandvik Cormont, batting cleanup on this one. In 5 years, where do you see the EV manufacturing market?
Yeah, globally, I think that Europe is going to be quicker to adapt all EVs. Locally, in the United States, I think we still have some questions. Some of it's because of the distance you travel. But that's where, like what Andrew's saying, an alternative source to to charge the battery, so if it's like a hybrid of hydrogen charging the electric or the battery, which runs the electric engine, we still are creating a sustainable source of water just coming out the exhaust. So I see that happening. I see us getting closer when it comes to that. I see us being able to, in 5 years, be able to 95% reprocess the whole battery, and that will be big. Then we can reuse it and create maybe an easier way on the environment. So sustainability will be a lot farther ahead in the future.
Awesome. Thank you, Rick. So that just about wraps us up today, but I want to thank our sponsors again, Festo, ISCAR, and Sandvik Cormont, and obviously a massive thank you to Jared Garby, Andrew Benson, and Rick Crabtree. Gentlemen, thank you so much for your time today.
Pleasure.
Thank you. My pleasure.
Thank you.
You can listen to all of our episodes of Manufacturing Matters and Lunch and Learn podcast from the MFG Radio Network on Spotify, Apple Music, and on our websites, today'smedicaldevelopments.com, aerospacemanufacturinganddesign.com, defenseandmunitions.com, and evdesignandmanufacturing.com.